Good afternoon, everyone. Uh, so, uh, as per the schedule, I'm not going to take introduction of every one of you. So I'll give just a brief introduction of myself. Myself, Dr. Prashant Verma. I did my PG and PhD from Banaras Hindu University in the Department of Statistics. Apart from that, I did work for TCS as a business analyst for 2 years. I've been working for SBI as a data scientist for 5 years. And now I'm working as assistant professor in the University of Allahabad Department of Statistics since May 2022. Uh, Without any further delay, I'll start my lecture. That is on the logistic regression. So I welcome every one of you for this session. Thank you. Am I audible? Is it working? Okay. So as I'm told that most of the audience is from non-statistics background, some are from medical background, like biostatistics and microbiology or some other life sciences or other social sciences background actually. So we'll not go to the mathematics and expression for the logistic regression, rather than we will try to get the concept and how it works, how you will use it in your research or in a particular use case basically. So have anybody done logistic regression before? How many of you have tried it? So I guess there are researcher as well from the different background. Anybody? Like okay, someone, yeah, okay, no problem. So what did you do actually? Basically, किस problem के लिए आपने किया था? What was your domain? Sorry. Okay, it was an economics data. Okay, you were trying do the logistic regression. My question is, so whenever we talk about the logistic regression, we have heard about the regression. So what is the difference between regression and logistic regression? Anybody? So we'll start from here. So how will we identify whether a problem belongs to the classification problem or a regression problem? You must have heard about the dependent variable and the independent variable. So independent variable are also called like outcome variable, target variable. Okay, independent variable. So problem, how will we define it? It will depend on our output variable that we call it y. So you must have heard that equation y equals to alpha plus beta x plus epsilon. Have you heard it? So there y is your outcome variable. So we will identify on which scale the variable is. Okay. After that, we will decide whether it is a regression problem or a classification problem. So have you heard about this? Scales of measurement. So before starting doing any regression, suppose you are having a multiple linear regression or ordinal regression or logistic regression, multinomial logistic regression, first thing is to identify on which scale is your target variable. Okay. Have you heard about these terms, scales of measurements? Okay. You are aware of it. Okay. So when we talk about the classification problem, in the classification problem, outcome variable should be on either nominal scale or ordinal scale. There is another name for these two scales. We call it data is or categorical. It's a categorical data. Why? Because in that those variables, the values will be classes or categories. Okay. So these are about nominal, ordinal. Nominal is a kind of identification, like your roll number, your customer ID, okay, or other identification variables. So can we have other example of nominal variable? The variable which are on nominal scale, male and female, okay. So how will you identify the nominal scale? You cannot do any mathematical calculation on that. Okay, can we say that females are 1.5 better than male or 1.5 times male, like that? Can we say it? It can be a subjective debate based on your subjective experience. Okay, in your class, you often have that discussion or debate who is better, man or woman. Okay, another example like religion. It's again on the nominal scale. Okay, so you may have a some kind of subjective belief that certain kind of religion is better than other religion. But should we do it? So better way to reduce these kind of conflicts. So whenever you see a variable is on nominal scale, so don't compare it. Okay, it will reduce the 90% of the problem that society is facing. Okay, in terms of gender, place of residence, ethnicity. Okay, what else? Nationality. What else? Religion, caste. Okay, so whenever the variable is on nominal scale, don't compare it. Don't argue on that. Okay, so I think few of them from the social science background as well. So they must be aware of these things. Okay, so it's ordinal variable. It is categorical in nature. What is the difference between nominal and ordinal? We can order it. We can give a rank to it. Suppose based on the marks, you are giving the ranks to the students. Okay. Anybody from psychology background? Okay. So you must have using skills for the different phenomena of psychology like depression and anxiety. So what you do in that scale or key, it's a questionnaire that asks on the Likert scale. Okay. Likert scale. Suppose you are doing for some kind of customer survey, customer satisfaction survey. You will have that categories in that. Okay, like extremely satisfied, satisfied, somewhat satisfied, dissatisfied, extremely dissatisfied, like that. So those kind of variables we call the ordinal. We can order those classes, but in nominal we cannot order it. We cannot say that men are better than women or women are better than men, like that. Okay, so this is quite confusing. Interval and ratio. We often have that confusion in mind whether the variable is in interval scale or a ratio scale. So the difference is both the scales, the variable, either it is on interval scale or the ratio scale, it will be a numeric kind of variable, quantitative. Okay. Main difference is absolute zero, the true zero we talk about. Right. For example, here it is written that temperature in Celsius or the Fahrenheit. Okay. So what happens? Suppose for a particular day, in a particular geographical region, temperature is 0 degrees Celsius. Can we say that there is no temperature or there is an absence of temperature? Temperature is there. So 0 doesn't say that that particular attribute is absent. When you get to know that there is a temperature, if you touch ice of 0 degrees Celsius, you will say it's cold. When the heat transfers, you will get to know there is a temperature. That's why heat is being transferred. It can take the negative values as well, minus 20 degree, minus 30 degree. Okay. So here 0 doesn't represent absent of the attribute. So whenever a variable has this kind of situation where 0 doesn't mean absence of that attribute, it will be on interval scale. Another is the ratio scale. So before, why we are thinking about this? So before building any model or doing any analysis, we should know variable first. You must have heard about the data visualization, data exploration, right? So when you are working on a problem and it is domain specific, it's very necessary to understand your data. Okay, so last one is the ratio scale. So it will have the absolute zero or the true zero. Other things are same. It will also be on a numeric type. It will be a numeric quantitative type of variable. It will have the absolute zero. Can we have an example for this ratio? It can be integer or it can be in the decimal as well. Okay. Uh, can we have one example for this ratio scale? Which variable should be on ratio scale? Can we? Temperature in galaxy. Okay, how? How? How it happened actually? Yes. So, yes. What is the maximum negative temperature possible in that phenomena? It's minus 273. Okay. If we scale it to 0, then we convert it to Kelvin. Now it is on ratio scale. And we have some other variable as well from your domain, whether it is a psychology, economics, or something else. Income. Why? Suppose students are sitting here. Ask them, what is your salary? So income. We are collecting the data. If a certain variable saying income, and someone says, I don't have any income. So it will say, what will you put in the data? 0. That means the income attribute is absent there basically. There is no income. So that is the basic difference between the ratio and interval scale. So I hope that is clear now how to differentiate the interval scale and ratio scale. Now come to the previous point that when we were talking about the regression classification. So when we talk about the regression, our target variable or outcome variable should be on which scale? It should be quantitative in nature. Okay. So it can either be on the interval scale or ratio scale. Okay. Suppose for your psychological some test, like for anxiety, you get the information from the respondent and you have some index. What is the score basically based on the certain scale that you call to the questionnaire. Okay. So that is it with scale. Currently, it's an quantitative in nature. Okay. So it will be, can it be negative? Now, it will be a ratio scale. Okay. You can categorize it. Suppose a score less than 150, you can categorize it no anxiety. 150 to 175, moderate. 175 to 200, it can be high. Like that. Now your variable will become which kind of, on which scale it will be? Ordinal, because you can order it. Okay. Because it's low, moderate, and high. You can do it. Okay. So whenever the variable is, your target variable is on ratio or interval scale or quantitative in nature, it will be numbers. Okay, right? Either it can be a discrete number or continuous number. Continuous number means it can take the decimal values. Okay. It will be a problem of regression. On the other side, classification. When we talk about the classification, it means your target variable or outcome variable or your Y will be a categorical variable. Okay. Categorical variable means a variable can get a different categories. Like suppose you have taken one loan from a bank. Okay. Either you will repay it or become a default. There are two options. So it's a binary kind of output for a particular customer. Either it can be default or default. Okay. So this kind of uh, variable will be binary variable. It can be a multi-class problem as well. Suppose some variable can have 3 categories. Okay. Like for economics students, uh, we are talking about the income only. Okay. So we have the continuous values or quantitative values for income. Can we categorize it? So we can categorize in, suppose we categorize in 3 classes, like low income, moderate income, and high income. Now, in this case, it will become a classification problem because your target variable, your output variable, is a flat scale, ordinal scale, or categorical. So I think I'm clear with this. Okay, everybody? Yes. Yeah. Okay. Yeah. In quantitative, when we talk about these two variables, it can be discrete or continuous. If we take the example of the income, it can be exactly $2,000, or it can be $12,005. But moreover, when you see on your salary slip, it will be continuous. Like some taxes will be there, some deduction will be there. It will be in decimals. Okay. Suppose your salary is 70,000. So it will be 70,595 point something. Okay. In real life, you will see that data. Okay. Most of the time, you will get the decimal. Yeah. Okay. Great. So now, what is the logistic regression? What a logistic regression can do? It can classify objects or respondents in different classes. It predicts which class particular respondent or a particular data point will fall in. It can be a two-class problem. It is written here binary or multi-class problem. Okay, so target variable can have two values, two classes, or more than two classes. It can be three class or four class or something. Okay. The thing is, when the classes becomes higher, especially up five or six or seven, it will be very difficult to model this situation. Okay. When you talk about the logistic regression, it's a classification model. Why we call it model? Model is nothing but creating an equation that can fit a real life phenomena. Okay, that is model. A model can be subjective based on the experience. A model can be objective like this logistic regression because there is a certain equation for that. There are certain estimations for that. Okay. The second is it is widely used method for the predicting the probability of an instance belonging to a specific class. Okay. So what it does, suppose there is a medical data, okay, for cancer. So there were certain patients who were diagnosed, okay. So biopsy was done for them. So some will have the malignancy in the test, some will not. So malignancy means you have the cancerous cell, or we call it carcinoma. So it is two class problem. Now, based on the previous data or the available data, can we do a prediction for the future that what is the probability, what is the chances that a new patient will have a cancer? When we do it, we can model this based on the previous data. So, apart from this information that biopsy was positive or negative, okay, it was malignancy or not, there will be some demographic characteristics to those patients. There will be some socioeconomic characteristics. Okay, wealth will be there. Okay, wealth index will be there. Age will be there. Gender will be there. Okay, place of residence. The other variables will be there. So based on those variables, uh, taking help from those variables, we can predict outcome whether this person can have cancer or not with certain probability. That's why it's called the probabilistic model. They are a deterministic model and a probabilistic model. Deterministic model, you must have heard in the physics, okay, equation of motion. For the certain conditions, any one of you will calculate it, you will have the same answer. Okay, but in statistical models, the probabilistic models will have answers with some probability involved. We are saying that a particular patient will have the cancer with, for say, 0.7 probability. Okay, so we are 70% sure that the person will have carcinoma. Okay. So now in logistic regression, the independent variable can be categorical or numeric. Okay. So the independent variable can be it can either be in interval scale or ratio scale, and also categorical. It can be nominal and ordinal as well. Okay. Do you remember the linear regression? What was the condition there in linear regression? It should be continuous. Okay, that is the difference. So here we can have a continuous categorical variable as input. What we call it input. Input is nothing but independent variables like that we talk about. Okay, and the categorical outcome for the dependent variable. As we discussed, the output variable or outcome variable will be categorical. Now we are talking about the types of logistic regression. So there are two types of logistic regression we have seen. One is binary logistic regression, and second is multinomial logistic regression. What is the difference? So in binary logistic regression, the output variable or target variable will have only two values. Like for our example, it was the cancerous and non-cancerous. Okay, it can be more than three variables. Sorry, three classes for the target variable, like income. Based on some characteristics, we want to predict income of a person. So it was low, moderate, and high. It can be three classes. You can think of some other use cases where the classes are more than three or four or four or five. Okay, especially in case of the risk, we can make four categories. In case of psychological research, we can make four classes or five classes for a particular phenomena, like level of depression or level of anxiety a person is having. Okay, that is the basic difference between binary logistic and multinomial logistic regression. Okay, so as we were discussed, independent variables, those are affecting our dependent variables. It can be either categorical or continuous in case of logistic regression. The second point is the model takes these as input and make predictions about the probability of an instance belonging to category of response variable. What it will do? These inputs means the independent variable. It will predict the class of the output variable using input variable. This independent variables. Okay. So for example, if you want to predict heart disease, the dependent variable will be age, cholesterol level, blood pressure, etc. Okay. So what these variables affect if the person is having heart disease? So there's a well-known findings for that. Okay, there are so many research that cholesterol, age, and these other variables, blood pressure and sugar, that is responsible for the heart attack. How the blood sugar is responsible for the high cholesterol level? Anybody from the medical background here? Community medicine or core medical background? I think maybe some online participants maybe from there. So what happens when you have extra sugar? What it does? It will increase your LDL, that is low density lipoprotein. That's the bad cholesterol. And remaining, what will it does? Okay, what it will do? Okay, it will increase the triglyceride level. Remaining sugar will increase the triglyceride level. So, anyways, these are the cholesterol. These are the lipid. Okay, bad cholesterol is LDL, good cholesterol is HDL, high density lipoprotein, and triglyceride as well. So when you see it, there are different components like total cholesterol and other that I just mentioned. Okay, so so it's very important to understand from the domain perspective. That's why for modeling any situation, a real life situation, we need the domain expertise. If I am not aware of the medical domain terms and their conditions, how these variables are associated, we're not able to make a model. We're not able to identify which characteristics will affect our output variables. So domain expertise is essential before building a model. Anyways, we already discussed this that the dependent variable or target variable, it can be either binary kind of variable that has two categories, or it can have more than two categories. Okay, so we call it binary class classification problem when we have the output variable in binary class. If it is a multi-class, we call it multi-class classification problem. So logistic regression is actually not a regression problem, though we call it regression, it's a classification problem. Clear? Okay, again, the same, I think the same thing is written here. Categorical variables for which we estimate the probability of a certain category. We want to predict a particular class of the output variable. Okay, cancer example, we want to predict if a person is going to have cancer or not. What is the probability that person will have the cancer? Okay. So for example, for the heart disease prediction, the dependent variable will be 1, means that is having the heart disease, and 0. So it's a binary kind of problem. 1, 0, it's a binary kind of problem. So we can use a binary logistic regression in this case. Now we often talk about the assumptions of logistic regression. So now there is a difference when we are studying about the theory of any model and when we are actually working on a real life problem or real life data. So can we have perfect correlation, perfect positive correlation in real life data? Can we have? Until you make a hypothetical or synthetic data to make it correlation coefficient equals to 1, it will not happen. Even two variables, the real life scenario, if they don't have association at all, if you compute the correlation coefficient, it will give you some value. It can be small value like 0.003. It will give you a value, even if it is a independent variables. So what happens in real life? Not all the assumption will follow. So there are different techniques. We can make this assumption correct, or we can see how the model is performing, and we can decide whether we can adjust with, you know, uh, the assumption when it's not following. Okay. So first one is the independence observation. Means we are taking the data from a different patient. Okay. So if patients are not related, okay, so doctor is there, patients come, and they have the information. They take the information in a questionnaire or in some sort of app or something. They will not correlate. So in this class also, person is the probability of having heart disease for one person will not depend on other. So observation should be independent. Whenever we are taking the observations, or observation should be independent. But if we talk about, if you remember the paired t-test, we used to have the paired data there. Okay, or some other condition. If you are doing a longitudinal study, then observation will be dependent. Okay, so first is independence observation. Second is the linearity. It does not compel, logistic regression does not compel the independent variable to be linearly related to the dependent variable. Okay, but other thing, it wants the continuous independent variable to be linearly related with the log log odds. Okay, log odds ratio of the predicting probability and outcome. Okay, so it does not compel us that the dependent variable should be linearly related with independent variable. Okay. Next is multicularity. So it affects the model. Okay, up to an extent. Multicularity. Have you heard about it? Multicularity. What is? when the independent variables has high correlation basically. So why is it a problem? If the independent variable are correlated with each other, why is it a problem? Because it will distort your models. Suppose x1 and x2 are highly correlated, means x1 will have the same effect on your outcome variable or y as x2 has. So it will distort our model. So this is something which is not recommended when we are using the logistic regression, that independent variable should not be having any multicollinearity. So there are different ways to address this. Like what? What we can do? We can see correlation matrix for the independent variable. Okay. So correlation matrix is this kind of the matrix that shows correlation between all the independent variable with each other. Okay. There are 5 variables: x1, x2, x3, x4, x5. So it will give you the correlation coefficient with x1 and x2, x1 and x3, x1 and x4, okay, each other. So what we can do, we can see which variables are highly correlated. Then again, the domain expertise will come into picture. Okay, suppose there are 2 variables, and we see both have the same effect on the y. Which one to take? We have to drop one variable in that case. It is recommended. Otherwise, the model will be distorted because both the variable are having the same effect on the outcome variable. Domain expert will say, okay, there is a clear-cut explanation for the variable x2 rather than x1. So for the explainability of the model, we will do x1 because x2 was making more sense to model the situation. It was better explainable. This is one of the ways. There are different ways to reduce the multicollinearity. There are VIF, variation inflation factor. We use that when we have huge number of the variable. Okay, especially in the business domain, when you have the 500 variables, 5,000 variables like that. So you cannot do it manually. So then you can use the VIF for reducing the multicollinearity or removing the variable basically. Those are highly correlated. Next is there should not be any outlier. Okay. Sorry, justification में? What is that subset selection method?
इसमें हम ये क्लासिफिकेशन करते हैं, इसमें जो हाईली कोरिलेटेड होते हैं हमारे डिस्टेंस वेरिएबल से, उनको हम यूज करते हैं रादर देन यूज सिंथेसिस ऑपरेशंस सेक्शन होता है.
Okay.
ये मैथड लॉजिस्टिक रिग्रेशन फॉरवर्ड सिलेक्शन मेथड या बैकवर्ड सिलेक्शन लॉजिस्टिक.
Okay. So the answer is we do not see the correlation between the independent variable and dependent variable in logistic regression directly. There is no assumption for the linearity between the dependent and independent variable. Problem was that when you put one x-axis and y-axis, you put suppose age in x-axis and in y-axis you put weight. You can see some kind of the linear relationship. If your y, that is the y-axis, your input variable is a binary kind of thing, either 0 or 1, it will not show a linear kind of relationship. That is why I discussed now, it will require your domain expertise. If your variable are limited, okay, suppose you are doing some surveys, you have 15 or 20 or 30 variables or 50 variables. You can see it with the help of correlation matrix. Correlation matrix will that way to find out the multicollinearity or removing it basically. Okay, you will get to know which variables are highly correlated. You have to drop one of them. Depends on explainability of the output variable. Input variable. Suppose there are two variables, those are highly correlated. We will keep the variable which have better explanation for the y. Okay.
That is, then again we have to check the correlation with the response predictor. How will we know that this is highly relatable to that?
No, actually, we in this case in logistic regression, we are not seeing the correlation coefficient between the independent variable and dependent variable. We are seeing the correlation among the independent variables only. Okay. Okay. Outliers. We are talking about the outliers. We understand it. Outliers. What are the outliers? Extreme values. Is there any graphical method? You must have heard about it. How to find the outlier? Box plot. No? We have heard it. We call it 5-point summary point or box or whiskers plot. So what it gives the minimum value, the maximum value, and all the three quartiles, and also the outlier. So there are certain uh, mathematical way to find out the outliers. Okay, when we see the theory of the box plot, you will see wherever the observation is greater than Q3 plus 1.5 into interquartile range, we call it outlier. So why is it harmful for our model? Because model is being trained on the general behavior of that particular variable. Outliers are there, model will be distorted. It will get confused. So there are different ways. Sometimes we truncate it with the maximum value or the third quartile or 3 sigma value. Different ways to do it. Okay, so we will see if the variable is having outlier. If there are certain variable having the outlier, might make the variable maximum limit of some kind of rule will be, so that there will be no outlier. Okay. Yeah. क्या होता है कि जब आप एक बार रन करोगे, ठीक है, आपको लॉग आउट्स मिलेंगे. लॉग आउट्स क्या आप मैन्युअली निकाल सकते हो? लॉग आउट्स मैन्युअली निकाल सकते हैं, मैथमेटिकली निकाल सकते हैं. तो जैसे हम करते हैं कि वी फाइंड which are the strong predictors. How we find it? What we do, especially in machine learning, what you do? You fit one, suppose random forest is a very common case. You fit the random forest, find out which are the strong predictor, and use the same predictor for other models like logistic or decision tree or ANN or something. Similar case is that. Okay. Yes. Sorry. So what is logos basically? Anybody? Anyone want to comment on that? Logos. What is odd basically? Probability. Okay. Okay. Suppose there is a binary class of class problem. Okay. There's 1 and 0. So there will be certain probability of ones. There will be certain probability of 0. Okay. So we want it for the explanation of the independent variable, how it's affecting the dependent variable. For that, we need this odds ratio we call. Huh? Which estimation method we use in logistic regression? Anybody? Log likelihood will be there, obviously. Even in the output, you will see -2 log likelihood something. In output, you see it. What is that? Basically, it is used. Sorry. Yes, maximum likelihood estimation is used to estimate the coefficients basically. For any model, for any equation, our first aim is to estimate the coefficients. If we estimate the coefficients, we can get the outcome variable or the probability of the classes based on the xi's that we are given. Okay, so in the output we will see how it works. Okay. Now there are some use cases for the logistic regression here. So again, I think this is the same example that we were talking about. A doctor want to identify whether a person or patient is, is probable to have malignancy or not. Malignancy means there's a kind of cells basically. One is that belongs to malignancy, and second is benign cells. Benign cells means non-cancerous, and malignant means cancerous cell. So this is a binary kind of problem. We can do it from logistic regression. We can make a model for this. Or second one is the predicting a patient's likelihood being hypertensive or not. Again, this is a binary kind of problem. You will have the cutoff point for a blood pressure. Okay, anybody having a blood pressure more than this point will be hypertensive, otherwise non-hypertensive. So we can make a model based on his biomarkers and other information. Make a model, predict whether what is the probability. Likelihood means probability basically. What is the probability of that particular patient of having hypertension? Okay. Third one, I think it's a multi-class problem. Here we can use a multinomial logistic regression. So here it's prediction if a patient is likely to have high, moderate, or low level of anxiety. So there are three classes. It's a multi-class problem. You can predict it using the multinomial logistic regression. So these are some use cases, okay, which can be helpful for creating these models. Again, so we've already talked about it, how the logistic regression is different from the linear regression. Okay, so here it is. The linear regression is used for the predicting continuous numerical variable. We were talking about the linear regression. Outcome variable was continuous scale. And oppositely, in logistic regression, outcome variable will be categorical. It can be a nominal or ordinal scale. Okay. It models the relationship between independent variables and the dependent variables by fitting a linear equation. So if you make a scatter plot, okay, in case of the linear regression, when your outcome variable is continuous, you will see a different picture. If you try to fit that in the logistic regression, you will have a different picture. Okay. So what will happen? I think it's not working. Okay. Okay, I think I have some. Yes, start. No. I just wanted to this side. Okay. It was reversed. Yeah. I'm not comfortable with this, but I'll try to. Okay. So this is x-axis and y-axis. So maybe in the Chinese it's x-axis and y-axis. Okay. I hope you understand this. In what happens in this is your x, this is your y. In linear regression, this y will be the continuous variable. So you will put a scatter plot, okay, like that. So for each value of x, you will have a value of y. And if you want to fit some regression line, it will look like this. Okay. But if you talk about the logistic regression, what will happen? So Ry in that case will have only two values for the binary problem. One is 0 Why is it coming like this? Okay, consider it 1. For all the x size here, you will either have the points here or here, like that. So you will not be able to fit a linear line with that. You cannot use a linear equation for that. Okay, for that we need the transformation. You must have heard about the sigmoid function. For that, sigmoid activation function is used for this. That is a S-shaped curve. Okay, that transform our data within the range of 0 and 1. It will give the probability. So probability range from 0 to 1. It will give the probability particular event. Event means the class of that particular variable. Okay. Again, this I think this is the same thing as written here. In the linear regression, it will be a continuous variable, the dependent dependent variable, and in logistic can be a binary class or multi-class problem. So there are some example written here for if you want to predict some numeric variables, numeric value, like heart rate, your blood pressure, or your random blood sugar. These are the continuous values. No, it will have the continuous values. These variables. Heart rate, it will be some numeric values. VP will have the numeric values like that. So these are the example of the linear regression. And if you talk about the different categories here, okay. So these are the different categories. If you want to classify objects in these classes, this is classification problem of logistic regression or multinomial logistic regression. Okay, so now we will do some hands-on practice on it. Okay, everyone has got their laptops or something. Okay, if somebody is not having currently, he can share someone. Yeah. Which one? Linearity between. Okay, thing is, in linear regression or multiple linear regression, assumption is the independent variable should be linearly related to dependent variable. But in this case, because we need the transformation, okay, why? Because our output variable is having either 2 values or 3 values. It's categorical values. So we use the log odds. Log odds in case of continuous independent variable. Okay. In case of continuous independent variable, we use this assumption basically. We try to see that this assumption is working for us or not. Again, in the real life scenario, it's not necessary that all the assumption will follow. Then what is the way for you to build a model? Hit and trial is the method. Okay, you will try to build a model. Okay, try to prepare your data as per the requirement of the model and try to fit it, try to examine it. Then you can see, okay, even if the some assumption is violating, the model is performing well, we can opt it, okay, for deployment. Why we do the modeling? Modeling, we do it for that, so that we can predict something in future, okay, so that it can contribute to the society or whatever the domain you are working, okay. So I think everyone has that data. You have the data, everyone? Everyone opened the data, okay. Is there any, what is the last variable in your data? Can you see it? Heart disease, no? Okay, okay. This is the data that we are going to model. So in this data, what do you think? What should be the outcome variable? or the target variable in this case? And yes, heart disease. Okay, then the heart disease. Can it be fasting blood sugar if it is containing 0 and 1 values? Means 0 means the patient is not having fasting blood sugar, and 1 means it is having the fasting blood sugar. We can model in that case also. Okay, for this case, this is our output or target variable. Clear? Everyone has the data. Okay, so this is the data overview. We have age, sex, chest pain type, resting blood pressure, cholesterol level, fasting blood sugar, resting ECG, maximum heart rate, exercise angina, heart disease. Exercise angina, everyone knows. When do the exercise? If you are having some kind of chest pain or pain in the left hand, okay, most of the time doctors prescribe TMT test for that. Okay, there's a treadmill test. So if you are having some serious issues when you are exercising or giving pressure to your heart, then if you are having some discomfort or some abnormality, it may cause some heart problem. Okay, why these variables are there? So domain expertise, when he was collecting the data, he was having the information that blood sugar level will affect the cholesterol, and again the cholesterol may not may exactly actually it has the effect on the heart disease. Cholesterol is the major uh, uh, component of that. Again, age. Okay, so we explore the data. Okay, if the data is on the same scale that it should be. So the thing is, here in this problem, the data which are categorical are not given the numeric values, but it's always recommended to make these categories numeric values so that you select the reference category when you are building the model. Suppose it is male and female. It's recommended to make some recoding. You must be knowing about the recoding in SPSS. You can recode this variable. Suppose you give male to 1 and female 0. Okay. If everyone is offended, he can give 1 to female, 0 to man. No problem. Then you can select the reference category. There should not be any controversy about it. Okay. So we will just see on the PPT what are the ways, what is the path to go and run your logistic regression. We will do it on our system as well. Okay. So this is the way we go to analyze. We have an option of regression in this. Then we can choose the binary logistic here. We have that option. Why? We have output variable of binary kind. It was having the 2 categories only. Person was having disease and not having the heart disease. Thank you. Okay. Okay. This one I entered. Okay. Okay, please. I was trying to change the slide actually. Okay. Okay. So this is the path. I think everyone is good with that. Okay. Okay. No problem. I can do it from there. No. No problem. कैसे क्रिएट करेंगे? Was it? Hmm? Okay, what we will do? Uh, Now I'm showing the PPT path to perform the logistic regression. After that, we will use the date on SPSS and demonstrate it. Finally, you can do. Okay, so this path is clear. The second uh, window you will see there, you can see the dependent variable and covariates. Covariates are nothing but your regression or independent variables. So in the case of logistic regression, dependent variable will be a Bandy class variable and independent will can be continuous or categorical variable. Can be both. Okay. So we can see the age is there, sex is there. So we have the categorical and non-categorical variable as well, continuous variable as well. In what we were doing in the linear regression, it was a stick to continuous variable. It is here we can use the categorical variable as well. Okay. One thing is written here. If we have hundreds of thousands of the independent variables, how do we select the important predictors? Okay. So we were talking about the correlation matrix previously. How can we choose it? Or up to an extent, a domain expert can suggest which variable can be the strong predictor for that. Okay. So there are different ways. Domain expertise will be used. Your correlation matrix can be used. Okay, yeah, there are different VIF techniques are there that will also remove your multicollinearity that can help you selecting the strong predictors. Other things are also there that we can choose the strong predictor using some other classification model, machine learning models. Most of the times, it's a convention to use a random forest to have to select the strong predictors. Basically, we can run the random forest, have the strong predictors, and we can choose those predictors for our logistic regression model. You can do it. Okay. So now covariates are put here in this category, and method is by default is enter. Okay. Now the selection variable. If you want to make some rule, okay. So you want to make layers for your model. Suppose you want to build a model for particular variable for the different classes. It will provide you different models for each classes. You can select that variable. We are not going to take this. Okay. Okay. So what you want in the output, what you want to save. So now the thing is probabilities and group memberships will select. So what is that? What is the probabilities? Probabilities will provide you probability of that particular event or particular class or the particular row or respondent. And based on the cutoff, but do you know the by default cutoff for logistic regression or any other classification models? In general, yes, we take 0.5 as default. Okay, we will talk about it. What happens? We can choose it with the trial and error method. Suppose model is giving you 76% of accuracy on the threshold 0.5. That is by default. But you can try changing this threshold of suppose you are trying 0.6 or 0.7 and see it may happen that the accuracy of that model may increase or decrease. So you will have the trial and error method for the different cutoff of the probabilities or different threshold, and you will decide what is the best cutoff for modeling this particular phenomena. Okay. Okay. So okay, when you put the Bandy logistic, so what happens when you usually uh, build the model logistic model Bandy logistic? We only give this table basically. Have you seen this table? 4. So these are nothing but the log odds. Exponential beta that comes from the estimation of MLE in the case of logistic regression, that is nothing but the log odds. Suppose a variable, this variable has two categories, male and female, and the log, if the log odds is 1, what does it mean? Means probability of having a heart disease in male is equal to female. There is no difference in the category. So that's why it's a log odds. Okay, it's odds ratio we call it. So in general, we provide this table, but we do not see if the logistic regression is performing well enough to build this model and do the future prediction. We don't know. For that, one table is necessary that we are going to see. It's basically it is called the confusion matrix for the trained or fitted model. We fit a model. Fitting is nothing but a training a model. Okay. So in machine learning, we call it training a model. So this is the confusion matrix for the particular case. And what we see it. Suppose these are our predicted outcomes that our model is predicting. Okay. 0 and 1. 1 means person is having heart disease and 0 means not having a heart disease. These are the observed values. Observed values are nothing but actual values in the data. So what we are seeing that we are giving all the data to the model, all the independent variable along with the dependent variable, and see how good the data is being trained. Okay. So model has seen complete data, and this is the confusion matrix. This is the observed means actual values. Zeros, people are not having heart disease. 1, people are having the heart disease. So in that case, what is the correct classification for our model? If a model says that a person is going to have heart disease and he's actually having the heart disease, that's a correct classification. Or if the model is saying that this person is not going to have the heart disease and actually is didn't, that means it's a correct classification. Other two conditions will be the misclassification. So if you want to see the correct classification, what it should be? Your model says 0 and actually it was 0, means those were not having the heart disease. So this is the correct classification model has made for our training data set. Here, once means the patients who were predicted by the model that they will have the heart disease and they were actually having the heart disease, it was 407. So what will be our correct classification here? The diagonal, the diagonal part of it, it will be the correct classification. Will it work here? Okay. It's not easy for me. Okay. So this diagonal part is the correct classification. Okay. Model said it's 0. Actually, it was 0. So this is the correct classification. This is the correct classification. So how will you measure it? The accuracy. Accuracy is given there. How will you measure it? We will add this correct classification and divided by the total number of the cases, and we see accuracy. We'll multiply by 100. We will see the formulas later. Okay. And the part we can see here, the correct ones. So this is called the sensitivity, and correctly classified 0 is specificity. Okay. So actually there were 410 total non-event cases. Out of them, 310 was correctly classified as 0. So this is specificity for this model, and here 407 out of 508, summing up it was a total ones in the actual data. It was correctly classified. How will you identify it? 407 divided by 508 multiplied by 100. In percentage, you can have this 80%. So we cannot rely only on the accuracy. Why so? We have to see accuracy, sensitivity, and specificity together. Is there any chance that we can have a very good accuracy, but model is not able to identify enough or between 1 and 0? How will it happen? So what is the total of it? Something total. 900 and something. Okay, 917. Okay, total cases. If the model says that okay. What is the cursor? Okay, they got it. Okay. So 0, 1, and 0, 1, and we have this. Is it looking like a game? Huh? Okay. Suppose our model predicted everything as 0. So it was suppose 900. Yeah, bhai. Okay, can you see it? What it did, that is a very common case when you see in the large data set, especially in the business atmosphere, you can see such situation with the data, where the model predicted everything as 0. So what will happen? If you try to find out the accuracy, what will be the accuracy? It will be 100%. But is it a good model with identifying 0 and 1 separately? Good. Not performing well. It's not performing at all, actually. It's saying everything is 0. Our accuracy says it's 100%. So it's very necessary to parallelly see the sensitivity and specificity as well, along with the accuracy of the model. There are different parameters as well, like precision, recall, and F1 score, that have more or less the same concept to check the model evaluation. We will evaluate the model, no? That is the difference. In general, what we do, we just give the table of the log odds and we give the interpretation of the independent variable and dependent variable, and that's it. We don't see whether the model is fitted well or trained well, and what is the accuracy of that model. So it's again important. So this is a confusion matrix for particular. Suppose it's example for the disorder and not disorder. Okay. Suppose you are talking about the HIV cases. Okay. So the test result was your model basically. That your test scale is a model. What it does, it yes, it identifies what are the positive results are there, what are the negative results are there. So if the person is having a disorder and the model is saying, or model or key, it is the model in that case. Okay. So that particular scale or test is based on some statistical tool as well. Okay. Have you seen the reports somewhere? Means Vidal test or CBC or something. In the bottom, they write the reference of that particular test. Okay. By this method, this is calculated. Under this method, this is this. Under this reference, these are the values. You can see it. Okay. So it's nothing but a model in that case. Okay. So it was the person was having the disorder. Our test find out is that the positive test result means he's having the disorder. or HIV case in our example, it's true positive. Similarly, if the person is not having the disorder, your test is saying it's having the disorder. It's a false positive. False positive means the model is saying it's positive, but actually it's not. Okay. Similarly, for the negative test result, we have the false negative and true negative. So person was not having the disorder and the test result was negative. This part is the true negative and this is false negative. Why? Because the person was actually having the disorder. So this is something reverse of that what we see there. In that case, the upper side was the predicted value, here it was the observed value. But in this case, here are the actual value or the observed value, and this is the predicted value by the model or test. Okay, this concept is clear. So this is basically the concept of the correct classification and misclassification. Okay, so these are the simple formulas for calculating the accuracy, sensitivity, and specificity. Okay, for the model, you have to identify it. It's very simple. True positive plus true negative. The diagonal that we were talking about, true positive and true negative. The sum of the true positive or the correct classification. True means correct classification. True positive plus true negative divided by total instances means number of observation or number of the patient or number of the people in your data set. Okay, the number of the rows. If you recall of the Excel how the data is prepared. Rows means number of individuals or observation, and columns are the characteristics of variable. Correct. Now the sensitivity. In the case of sensitivity, what we see whether the model is able to identify the true cases or the cases, events basically. Person who was having HIV, the ones in our problem. True positive divided by true positive plus false negative means person who are having the model is able to identify out of the total positive cases how many model is able to identify. Okay, total positive cases, fully positive cases, how many model is able to identify. Suppose there are 100 positive cases in our study. Actually, after the test is conducted, 100 cases. But once we train the model, our logistic regression model was identifying 70 events or 70 disordered person. What it means? It is that the sensitivity of our model is 70%. The similar case, we can talk about the non-event, zeros. Okay, person who is not having that illness. Okay, where the HIV test is negative, you can do it. So it should be balanced. It should not be that model is very well is performing very well for the ones, not performing well for the zero. It's not a good model. It should be a balanced one. Okay. Similarly, for the specificity, you have the true negatives and divided by true negatives plus false positive. Simply, you can see the correlation matrix and you can find out these parameters for the model evaluation basically. So in that we discussed already, I'll just give one interpretation for this. Suppose if we talk about the age, how the age is affecting the heart disease. Okay, so now it comes the interpretation part. What happens? We'll see the log odds, that exponential beta that is found after the maximum likelihood estimation of the logistic regression. So this is nothing but odds ratio basically. Okay, so age, it's 1.024. And again, before checking this, we have to find out whether the variable is significant or not. If we are taking the 95% level of confidence interval or level of confidence, we can see the value which are less than 0.05 are significant at the 5% level significance. If it is less than, p-value is less than 0.01, it's significant at the 1% level of significance. What it means, this 95% of 1%, sorry, 5% of 1%, means for the 5% level of significance, we are 95% sure that our finding or what we are interpreting is true. It's a 95% confidence surety. Okay, there are 5% of error will be there. Okay, so what will the interpretation? This variable, the p-value of the age variable is less than 0.05. It's significant at 95%, and exponential beta is 1.02. What it says, on the increase of the 1 unit in age, percent more risk of heart disease will be. Okay, if the age is increased by 1 unit or 1 year, the risk of heart disease will increase by 2%. Or in other way, we can call it, it will be 1.02 times. The probability of getting a heart disease, if we increase the age by 1 unit, the chance will be 1.02 times. Okay, similarly for the sex. So it's by default it's taking 1 first category. In our data set, as I was saying that it's recommended to recode your variable if it in the string time to make like 1 2 3 4 or 0 1 2 3 4. Okay, it will be very easy to the reference category. In our data set, the model find the male at the first place. So here 1 means the result is coming in respect of the male, means the reference category is male. In comparison to the male, female are having 100 minus 31. Okay. So how much it is? 69. 69% more chance of getting heart disease. So you will be either having a continuous variable as dependent variable. You can explain in that way, unit increase, or in case of the categorical variable, you will have the probabilities getting that disease in terms of reference category. There are different methods also for this. We make the dummy variable as well for the categorical variable. Okay, so you can have a look at how to make the dummy variable as well. Okay. Most influencing on basis of what? No, it's just respect to that variable. It's just for the explanation basically. Here we cannot compare it, but there are different methods that we can find out which are the strong predictors for that. Okay. Definitely changing in that fasting blood sugar. We are clearly having that increasing the blood sugar with the 1 unit, we are getting 3.24 times likelihood of getting a heart disease. Okay, so that impact is clear and it's huge. Okay, you can interpret in that way. So I think we'll go to the data. So then the question is the logistic regression an ML technique? What the ML does, machine learning does, it trains with the data and provide outcome or do the predictions. Same thing it's doing. No, linear regression, multiple linear regression, logistic regression are the machine learning techniques. In your homework, you can find out what is the precision, recall, F1 score, and how to interpret it. You got the idea of sensitivity and specificity. and accuracy. So there are some other metrics as well. Precision, recall, and FN score. You can see it. How to calculate it. There is a different uh, explanation for that, but there is a similarity between these two as well. Okay, as I suggested, always create or relabel your categorical variable in terms of numbers. Okay, we will get to know, okay, which category we should take as a reference. Okay, so what was the path? Can anybody suggest me? Analyze, analyze, regression, binary logistic. So which variable should I put in the dependent? Heart disease. If for this instance, we can put all the variables as covariates. Correct? One important thing, if any identification type of variable is there in your in your data set, like serial number, unique ID, primary key or something, identification number, don't put in the model. It will distort your model. It will give you the 100% accuracy. Okay, it's overfitting case. So don't put any identification in your model, identification type of variable. Okay, like serial number and IDs. Okay, so in that case, uh, can we see? Okay, gender is there. Okay, so there is an option to select what reference category you want. You want the probabilities of that particular event with respect to male or with respect to female, in comparison to male or in comparison to female. Okay, so first we will run it by default, and we will save the probabilities and group membership here. Okay, as was mentioned in the PPT. So we will just go to the output. So now the beginning block we will remove, we will ignore it because it says if you are not considering any independent variable. So the model is not trained yet. So we will go to the first one, the answer method. The thing is, rather than referring to the R square values, we will rely on the confusion matrix. Why? Because it's not a regression problem. In regression problem, we often see the R square and adjusted R square. In the classification problem, it's recommended that we should evaluate the model on the basis of confusion matrix. So here it's a confusion matrix. What it says? It says the model is able to predict the heart disease cases with the accuracy of 81.6%. And now we will talk about the sensitivity. It's 1 in 1. It's 428. This is 54%. So out of the total cases of heart disease, the model is able to identify out of total cases 84.4%. That is sensitivity. And for the specificity, the model is able to identify the not event cases or the person who are not going to have the heart disease with 78%. So there should be a balance with that. It should not be like identity. It's giving a good accuracy. The model is having 84% of the sensitivity, but specificity of suppose if it is suppose percent, it's not a balanced model. It's able to identify ones well, but not the zeros. That will impact your overall accuracy. Okay. Again, this is a table that we already explained how to interpret the variable. So one was the age, that was the continuous variable. Second was the uh, which okay, gender, that was the categorical variable. Okay, we got interpretation how to interpret these two kind of variables. So one more thing. Now, as default, when it was taking the last category as a reference category, it was giving the odds ratio of 0.313. Okay, for gender means it is giving the likelihood of the heart disease in women compared men. Okay, how can you change? If you want to make the interpretation in the other way around, what you will do, you will do the same exercise here. So when we are going to category, you can change particular categorical variable. This is only for the categorical variable. Reference category. There is no reference category in continuous variable. In categorical variable, we choose the reference category. So it says by default, the reference category is the last one. Let's change it to the first one and click on change. Okay. Now for the gender, again, I'm saying I'm repeating it. Change your continuous variable classes to the numbers. Okay, it will be easy to understand which is the first category and which is the last category. Okay. So now we'll see how it changes. Now your odds ratio comes in terms of risk of the heart disease among men compared to women. So they are 3.19 times higher likelihood in men for having the heart disease. Probability के terms में. So we usually because it's 3 times. Okay. If you say it's 319%, can we say it? Maximum we talk about 100%. We can say it 300%. There are two ways in terms of multiplication, explaining in the terms of multiplication or in terms of percentages. One means if it comes to 1, okay, the gender exponential beta comes to 1. What does it mean? That means this odds ratio basically, risk in men divided by risk in women. If it comes 1 means there is no difference in terms of the probability of having the heart disease, both the genders. Correct. You can change the reference category as per the way you want to explain your problem. You want to address your problem. You want to interpret your model or this phenomenon. Okay. So I think that is done from my end. If you have any question, I'll be happy to answer you. Sorry? Yes.
Sir, could you demonstrate the method of analysis of multinomial regression?
Okay. So in that same path, when you go to the analysis, regression, and primary logistic regression, you will have the multinomial regression model where you can choose that. Okay. Under what condition will you use it? Is there any condition for using the multinomial regression?
The option is and factors in covariates. So what will put in factors?
Okay. Factors, you can put, suppose you want a results, particularly, suppose for the gender. Okay. For the gender, you want a different interpretation for different models. So you can choose that. So by default, I'll suggest you try one data, okay, that has multi-class, more than 2 classes. You just have it, supply it to the model and see what it does. Okay, once you are putting in the covariates and when you are putting in the independent variables or factors and putting few variables in the factors and few variables in the independent variable. Okay, so you can explore that apart from your this thing. I was talking about the Frisian equivalent F1 score. You can try it.
We did figure it. So we have high. So which method we use in binary or multinomial?
So it's a multi-class problem. You can think of the multinomial logistic because it's a more than two category. But the thing is, if you are having a variable target variable which is a type of ordinal, which is on ordinal scale, you can use the ordinal regression in that case as well. You have the ordinal scale, ordinal regression in your spaces as well. You can try it and see which model is giving more accuracy, which model is performing better. For model perspective, yeah.
Why is it called confusion?
Okay, why did call a confusion matrix? Because because for the human also, how we learn? We learn from the past experiences and we try to predict something. Okay, so last year there was a convocation in the university, and we were in charge of the food. Okay, so we had that data, we had that experience. So how much particular goods and materials we should buy. So we will use that data, and in future, if that the same event is going to happen, we will use that information and predict that. But even if we have the past experience or the past data, we can get the misclassification and we can get confused. What happens in the misclassification? What was model and model doing? It was predicting some of the positive cases to the negative cases. So that's why it's called confusion matrix. Anything else? So that's from my end. Thank you so much. You've been a wonderful audience.